Hello, my name's Steve and I'm a junior data scientist at Lampada Digital Solutions, where we're developing an Internet of Things framework for use with industrial sensors. So, what is the Internet of Things? Well, the things are a set of physical devices which can be connected via a network. The devices are embedded with sensors and transceivers used to transmit data to a central hub before analytics can be performed. Performing analytics can offer some valuable insights and feedback, primarily to business managers and decision makers, but it could also activate an automatic process. So, let's think of an example of how this could be used. Let's say that you're the manager of a small potato farm. The first thing an Internet of Things framework could do is help to ensure that your farm is running efficiently. Things like preventative maintenance alerts, notifying you when to turn on sprinklers because moisture sensors read that the ground is too dry, or it could be that the acidity of the soil needs to be considered. Secondly, it could help ensure that your farm is running optimally. This could be knowing the right amount of water that needs to be supplied to your crop to maximise profits for your yield, or exactly what the pH of the soil should be. So, what does this look like when implemented? Starting with the sensor units, it could be simply placing a handful of helpful sensors at specific points on the farm. We've mentioned already that sensors can measure things like pH and moisture content. It could be things like temperature, light levels, airflow, or rainfall. Now we know it's unlikely for there to be power sockets scattered near each of the ideal sensor locations, so these sensors need to be low power consumers, possibly powered with batteries or even small solar panels. That's why we're using LP1 Technology, which stands for Low Power Wide Area Network. Typically, a sensor unit situated in its ideal location will consist of four main parts: the LP1 sensor, an electrical circuit board, power supply or generator, a LoRaWAN transceiver, which is a low power radio transmitter that sends and receives data up to a few kilometers. Where does it send the data to? Well, it would be ideal to send the data straight to the internet. However, that would require significant power which the LP1 sensor units don't have to spare. Instead, initially, all of the data is sent to a local gateway, located somewhere near the potato farmer's Wi-Fi router. From here, it can then be forwarded to the internet into a cloud storage service, where the data can then be processed. What happens when the data is processed? In terms of efficiency, it could be used for just supplying the user with a near real-time diagnostic or measurements through an app-based dashboard. It may be that it's used to initiate an automatic triggering of a certain system, for example irrigation pumps if there's too much water. It may be that a flag is raised to the relevant farmer, giving them the ability to assess and monitor certain types of changes and readings for themselves. In terms of optimization, it could also be used with machine learning, that is artificial intelligence algorithms, to understand and find the optimum actions that need to be taken to maximize yield given the current sensor readings. So how is machine learning used? When you have a lot of sensors giving readings over time, you're collecting a column of data for each of them. When humans look at a 2D graph made from two columns, it's really easy to see when there are patterns between the variables. However, with machine learning algorithms, really complex plots with lots of features plotted can reveal patterns that would be too complicated for the human eye to take in. The modelling of such a system like this can allow for predictions to be made. Now, many of the variables in farming are uncontrollable because of things like the weather, and there are a lot of different variables that can affect yield. The machine learning algorithms look at past data and it creates a best yield prediction equation, and this can offer insight into how the variables that can be controlled should be controlled to ensure that the greatest yield possible is achieved given the current sensor readings. This isn't limited to farming, but farming is a good example. Generalizing though, any system that can be monitored and optimized could be suitable for this type of network. In summary, the Internet of Things network has the potential to be scalable, automated, and customizable, ultimately optimizing and increasing efficiency through offering valuable insights.